Hey guys, welcome back. For today's lesson 4.2, we're going to be talking about rate of change and slope, and this is going to be a two episode video. We're going to break this into two parts. So today's goal is going to be calculate and interpret rate of change. Of course, we're talking about rate of change, and the other two, which talk about slope, we'll talk about those tomorrow. So up here it talks about rate of change and how it's a quantity that's changing with respect to another quantity. And usually on our graphs, it's usually the change in the y value with respect to the change in the x value. So the change in the range over the change in the domain. So the output divided by the input is usually how we set it up. You'll see it right here. It's mentioned there. By the way, these little triangles, I believe that's the Greek letter delta, meaning change. Okay, for our first example here, we want to find the rate of change of the function by using 2 points from a table. You got to remember that this right here is the y value, so that's going to be the numerator, so the change in y over the change in x. And you got to choose any two. They chose to do 12 and 24. And notice how they put the 24 first. So when you go to do the x values, you got to put the x first that matches 24. So 24 and the 4 go together. So the y here and the x here are matching as part of the same ordered pair. So anyway, we subtract them, and 24 minus 12, that's going to give me 12. Let me write that out there. That's going to give me 12, and over 4 minus 2, which is 2, so that's going to give me 12 over 2, or we can reduce that to 6 over 1. So this, we would describe the rate is 6 over 1, or plain old 6. And this means that you could make 6, remember this top number right here is representing pancakes. So this could make 6 pancakes for each cup of flour. The denominator here, which is 1, represents the denominator here, which is flour. And by the way, a little side note you might want to add to your foldable if you're doing this. Whenever you have a ratio or a rate that is compared to 1 on the bottom, that's called a unit rate. And when you want to compare things of different rates, you convert them into unit rates, and you compare the unit rates to see which one's bigger, which one's smaller. Go ahead and pause the video and attempt to check. Okay, for this one, I'm going to choose just the first two up here, and I'm going to start with the 19.92 minus the 15.77. Notice I'm taking a point and subtracting 1 right behind it. Now this is the output, that's the y values that goes on top. Since I started with 19.92 on my first calculation, I got to start with 6 on my second, so 6 minus 4.75. Once we do our subtractions here, top portion is going to give us 4.15, and now remember that's the top portion here is dollars, so that's dollars, and the bottom portion is going to give us 1.25. and now the input or the denominator here was gallons, so that's in gallons, so that's representing $4.15 for every dollar, or 1.25 gallons. If I were to actually divide those two things out, and you may need a calculator in this context, we will end up getting 3.32 over 1. Now that's dollars over gallons, so 3.32 over 1, or in other words, that'd be $3.32 per gallon. For example 2, we're comparing rates of change again, only this time we're talking about student council and how much money they have here. So they have student council budget varies based on the fundraising of the previous year. So for part A, find the rate of change for 2000 to 2005. So 2000 is here to 2005 is here. So we're going to use the ordered pairs of 2000 and 1350, and then 2005 and 1675. And you see they actually put that over here for us already. So we go ahead and subtract those, and we end up with 325 over 5, and that comes out to 65 if we divide that out, so 65. This means that the student council's budget increased by $325 over the 5-year period with a rate of change of, and that's the rate of change right here, which is the unit rate of $65 per year. Okay, part B wants us to find a rate of change again, but they gave us 2 different years, 2010 to 2015. They've also populated it with the actual points that are in there. So the top numbers represents budget in dollars, and the bottom one is change in time. So our first subtraction up here is going to give us negative 225, and our bottom one is going to give us a 5. So time is progressing forward. If we divide that out, we end up getting 45. So this means that the student council budget was reduced. The reason this is coming out to a negative is because it's reduced. It's reduced by 225. We don't have to put a negative on there because the word reduce is in front of it. Over the 5-year period, with a rate of change of, and then they put a negative right here to tell us which direction the rate changed, and it is 45. So in this context, the negative there means that it went down at $45 per year. Go ahead and pause the video and attempt the check here. All right, for the check, they're telling us that the graph shows the average ticket price of Miami Dolphins football team. Find the rate of change in the ticket prices from 2009 to 2010. That's just 1 year. So 2009 is going to be the 2009 and the 6674, and 2010 is going to be these values right here, 2010 and 70.54. So we're going to subtract 70.54, and the other one was this number, which was 66.74. And that's going to be over 2010 minus 2009, which is really just going to be over 1. And you'll see we end up with $3.80. That's per year. So $3.80, $3.80 per year. The ticket prices have the greatest rate of change between. Now, when they talk about the greatest rate of change, we're talking about the one that has the steepest line. So if you look at our lines that are on there, it appears that this one over here is the steepest line, and that occurs between the time value of 2013 and 2014. So 2013 to 2014. And part C, between blank and blank, the rate of change is negative. Okay, so negative means the graph is going down. So we can see the graph is going down right here. And of course, it's going down again over here where we had our greatest rate of change. So the first part of that is between, it looks like years 2010 and 2011. So 2010 and 2011. And then the last one was the 2013 and the 2014 season. Okay, for example 3, constant rate of change. They want us to determine whether a function is linear. If it is linear, it will have a constant rate of change. Okay, so find the change in the values of x and the change in the value of y. Notice that the rate of change in each pair of points is. And there's a couple ways you can do this. So you can start by doing the change in the y value over the change in the x. So we end up with a -3 minus a -5 over 8 minus 11. Now keep in mind that when we solve this, that we have a minus a negative, which is plus a positive. So this right here ends up being a 2, and this right here ends up being a -3. So we get a rate of change of -2/3. I'm going to write that down, but I should verify that. So -2/3. If it is -2/3, then the rate of change here and here should be the same. Remember, it's called a constant rate of change, so it's always the same. So to be 1 minus a -1 over 2 minus 5. And don't forget that minus a negative is really plus, so 1 plus 1 is really 2. And 2 minus 5 right here is going to give me a -3. So if I have a negative in the denominator, the whole thing is negative. So -2/3 is the same thing. So the rates of change are constant. So the function is linear. And the rate of change is -2/3. Okay, example 4, we're still doing the same thing, rate of change. Determine whether the function is linear. If it is, state the rate of change. In order to be linear, the function has to have a constant rate of change. So we'll calculate the first one right here and here. So -1 minus -4 over 29 minus 22. Keep in mind again, minus negative is plus a positive, so the top number here ends up being a 3. And the bottom number, 29 minus 22, is 7. So it looks like it has a rate of change of 3 over 7. Let's just double check that. I'm going to pick 2 different points. So right here we got 4 minus 1, so 4 minus 1. And up here we have 43 minus 36. And that one ends up being 3 over 7. So far it looks the same. However, if I look at the last set right here, the 6 and the 4, 6 minus 4, and then 50 minus 43, 50 minus 43, that ends up giving me 2 7s. You'll see that this rate does not match the other 2 rates. Okay, so the rate of change are not constant. Between some pairs of points, the rate of change was 3 7s, but between others it was 2 7s. Therefore, it is not a linear function. So something you might want to write down in your foldable: linear functions have a constant rate of change. Go ahead and pause the video and attempt to check. Okay, for this video, we got to complete the table so that the function is linear. In other words, it has to have a constant rate of change. All right, so the first thing I'm going to do is calculate the rate of change between here and here, because those are the only 2 complete points that I have to start with. So the top one will be 10.75 minus 7.5 and 10 minus 10.5. Okay, so the first one is going to give me, it looks like 3.25 over a negative 0.5 or 0.5. So I'm going to use this 3.25 over negative 0.5. So what that means is, as we're going forward, this is increasing by 3.25, and as we go forward, this one is decreasing by 0.5, so negative. So as I go forward one more time right here, I got to add another 3.25 to that, and that will end up giving me 14. So that one has to be a 14. And if you look at this right here, if I go this direction, that means I have to minus a negative 0.5 or minus 0.5. So if I take 10 and minus 0.5, you'll see I do end up with a 9.5. So what if I change directions? What if I go this direction? You can see going that direction, I'm going to be adding 0.5. And if I change the direction this way, I'm going to be subtracting 3.25 to fill my table out. So 7.5, and if I subtract 3.25 from it, I end up with 4.25. And of course, if I go 3.25 back, I'm at 1. And then if I go another 3.25, I'm here at negative 2.5 or 2.25. So now I want to add 0.5 to this, and I'll end up with 11.5. And then add another 0.5, and I'll end up with 12. Now if I take the difference between any 2 y's and any 2 x's on the table, I'll still end up with the same constant rate of change.